viewers, welcome to this live session, the first one in our course on mathematical finance. I am Siddhartha Chakrabarty. I am the instructor for the course, one of the two instructors for the course, and with me here is one of the TAs for the course, Sanjay Pan, who is helping out with the running of the course. Okay, let me just start off with answering some of the queries that were actually received through the online Google Doc form. So there was this query. So the first one was that there were two doubts from one of the participants of the course. The first question was, what is the exam pattern? If possible, then give some mock papers. So the exam pattern is going to be objective type completely. So you will have questions like entering a numerical answer, and also you will have questions involving choices where there could be one correct answer or there could be multiple correct answer. You please go through the assignments in detail along with the solutions, and that will give you some idea of what to expect in the exam. The second question is regarding the eligibility criteria to get certification. This eligibility criteria is been clearly spelled out in the course announcement. So I request you to please go through the course announcement to get the details of what is the eligibility criteria, what is the percentage cutoff. It is all well defined out there. Okay, so the second question has come from Hariom. And Hariom asks that please talk on applications of mathematical finance derivatives and most promising skills required in fintech. So this is a somewhat open-ended question, and I'll try to answer the main points. So typically in financial engineering, we basically look at two main problems. One is on pricing, and we have already looked at especially if you look at the week 6 lecture and the subsequent lectures that will become. And also you have looked at what is options. So a lot of questions in finance involve pricing of derivatives, and so that there are various sophisticated derivatives. Some of them are obviously much more complicated than your regular forwards, futures, or European option. So one key question for the finance industry as a whole is to get people to work on the sophisticated modeling of pricing such derivatives, and in this course we actually seek to look at address and basically talk about some of the basics or the building blocks of financial derivatives pricing in general. So there is one importance of this course and relevance of that in case of finance industry. Secondly, the other key question that is addressed in case of the finance industry is portfolio management and risk management, which is another important question, but we will not discuss much of that in detail except the part where we talked about the Markowitz framework and the capital asset pricing model and the capital market line, and this essentially pertains to one of the thrust areas of the finance industry, namely the management of funds and portfolios. And because of various sophisticated derivatives involved, the risks need to also be assessed in a correct way, and sufficient preemptive measures need to be taken to minimize those losses, and that is where financial risk management comes into the picture. So once you have done the course, this would be a good stepping stone to working in these two key areas that are the focus of finance industry, something that we had already pointed out in terms of the two Nobel Prize winning works, namely the Black-Scholes equation, which is the backbone of pricing of derivatives, and the portfolio theory, which is essentially the precursor to looking at how funds are managed, and as a consequence of which whatever risks come, how one can actually manage those risks. In particular, we have seen the risk management when we talked about minimization of the standard deviation or the variance of returns in case of a portfolio. Alright, so this addresses the question of Hollywood. I hope it does that. Now, next there is a question, there is a series of questions. Where there are actually three questions. The first question is that how do we graphically represent the minimum variance line and the explanation of two-front theorem, and which y naught mean is not equal according to the definition of minimum variance line, mean should be equal. Okay. I'll just briefly go over this. Graphically, the minimum variance line is the following. See, when you look at a portfolio, the portfolio essentially is represented by the weights of each of the assets in the portfolio. And once you have the weights, what you essentially then have is that you calculate your expected mean as the weighted sum of the expected means, and you look at the variance as the variance of the weighted sum of the returns of those assets. So on one hand, you essentially have the weights, and on the other hand, you have the consequent mu and sigma values, which are represented in the mu sigma diagram. Let's just switch to. So what I will do is I'll just show you this. So essentially, what you have is that when you talk about the minimum variance line, all you really have is basically you are minimizing the sigma v square, which is essentially minimization of WCW transpose such that your WM transpose equal to mu. That means you are fixing the return that you want to achieve, and WU transpose is equal to 1 for W belongings to Rn. So this is the weighted, the sum of the weights being equal to 1, and this is basically the expected return is fixed to be mu. So what essentially happens is, graphically this means that on your mu sigma plane, what you have is we have this graph, and for any given level of mu, this point here is going to be the minimum variance. So the portfolio is resulting from minima. So the problem of minimum variance line is equivalent to the minimization of the variance subject to the weights, the expected return being equal to mu. So in this case, suppose that I have I incorporate this particular condition, that the sum of the weighted sum of the means or the expected return is going to be mu. So once I have this mu, that means that any of these portfolios here in this region, all of them will have identical mu, and amongst them I'm interested in finding out the one with the smallest variance. So naturally I'm basically going to look at the leftmost point for the sigma axis. So for this particular value, this is going to be the minimum variance portfolio, and for this particular minimum variance portfolio, what is going to be the weights? Remember that this particular mu and the corresponding minimum sigma would have come from a certain set of weight vector W. So what this minimum variance line theorem says, that this weight is going to be nothing but W is equal to A mu plus B, where A and B are specified. So this means that as an investor, if you want a minimum variance portfolio and you say that, okay, I want my return to be mu, then you can immediately calculate the portfolio that you need by calculating this W using the formula. Now remember that for the same set of assets, your A and B is unchanged. So these are fixed, and the only thing that you vary is mu. So this means that any set of weights which results in points lying on this part, the entire curve, the boundary of the curve, those are written in the form A mu plus B. So again, just to reiterate the fact that suppose I want my return to be equal to some mu1, and instead of doing this entire optimization, what I can simply do is that I can start off with by calculating A and B, and the weight that I need in order to obtain a portfolio with expected return mu1 and minimum variance will be given by W is equal to A mu1 plus B. So suppose again somewhere here I want the expected return to be mu2. So in that case I know that my portfolio will have the weights A mu2 plus B. So essentially it basically gives you one formula from which you can generate a whole class of portfolios depending on what is your expected return. And the reason why this is called a minimum variance line is that these weights that you have, these weights in the weight plane. So if you have a 2 asset portfolio, this weight W, this will essentially in the W1 W2 plane. So suppose you have 2 assets, then the weights will be W1 W2. So then this W1 W2 for this will basically then be a straight line, something like this. In case you have 3 assets, this is going to be a plane. In case you have more than 3 assets, this is going to be a hyperplane, which of course you cannot visualize. So this was the first question about how you graphically interpret the minimum variance line. And secondly, this two-fund theorem is basically, in this case what you do is the following. The two-fund theorem states that if you choose 2 funds which are lying on the capital market line, then you can create a third fund or a third portfolio by simply taking a linear combination of these 2. So that means what you do is that, so suppose you have 2 funds, say I call this can I have the next page please? So suppose you have 2 funds so suppose I have 2 funds, say P1, P2, it's okay, I can use that. So basically what you do is that in the two-fund theorem, so these 2 funds are on the capital market line, and what you can do is that you can create any other portfolio out of these 2 portfolio by assigning, say, weight alpha and 1 minus alpha to the portfolios, and then basically you will essentially get your desired level of return. Suppose that your desired level of return is mu, so then accordingly using this mu you can actually get your so these 2 will have returns, expected returns mu1, mu2. So you can calculate your alpha using the formula that you have given in the lectures. So this means that you consider 2 portfolios, right, or with the 2 funds that we state in the theorem. The expected return of these 2 portfolios are respectively mu1 and mu2, and you want to basically get a fund whose expected return is mu. So instead of doing all the calculations all over again and figuring out what should be the weights, all you need to do is calculate your alpha involving mu1, mu2 and the mu that you want, and remember that your alpha will be given in terms of mu1, mu2 and mu, where mu1 and mu minus mu2 will be in the denominator. So to ensure that this is not defined, you will basically need that to be them to be unequal or distinct. And so once you have figured out what is going to be your alpha, then you assign the alpha weight to the first portfolio and 1 minus alpha weight to the second portfolio. So this means that suppose the portfolio weight is W1 for the portfolio 1, the weights are already known, and this is some vector W1, and for the portfolio 2 the weights are W2, then you basically the weight that you need for the new portfolio is going to be alpha into W1 plus 1 minus alpha into W2. So this is again going to be a vector of the same dimension as W1 and W2, but what this will do is that this portfolio with these particular weights, this is going to give you the expected return to be mu, which is what you want, provided that you have chosen your alpha appropriately as per the formula given in terms of mu, mu1 and mu2. Okay, so this person again has asked another question regarding the multiple assets and how the variance of the portfolio is WC, W transpose. So this question is something that I posted last night with all the detailed calculations. So please refer to the discussion forum where the detailed calculation actually has been given as a PDF file. All right, so Sanjay, can you please help with the lectures? Yes, so the third question that has come from this gentleman, I think that there is some concern about the yield, how this yield is being calculated. So what you do is the following. So I'll refer to the second lecture of second week in order to illustrate my point. So what you do is the following, that in that case, what are the coupons? The coupons are going to be C over N. So basically the maturity is T years and interval between payments is 1 over N, right? And so total number of periods is equal to T dot N is equal to M. So this basically means that every year there are n number of payments. So that means that the interval for each payment in a year is going to be 1 over n, and there is total is t number of years. So that means that if we have n payments per year and t is the total number of years, then the total number of such payments is going to be t into n. So t could be 10 years and n could be a monthly payment. So in that case n is going to be 12. So if t is 10 and n is equal to 12, then t into n is going to 12 into 10, which is 120 payments. Alright, so suppose that, can I have the next slide please? So suppose that PT is the, yeah, sure, please take your time. Okay, so suppose that PT is the, yeah, sure. So basically this means that if the current yield of the